Hi, welcome to Chapter 6 Test Review, Part 1 for Algebra 2. Okay, so first I look kind of at growth or decay for exponential models. I first look and see whatever has the exponent. In this case, 1/2 is less than 1. So I would say this is a decay model. Here, 3 is greater than 1. So this is actually a growth model. Now, for C and D, I notice that my exponent is by an E. So I look to see if it is positive or negative. Because this is negative, we have a decay model. And because this one is positive, we have a growth model. Number 2, graph the function using at least 3 points. So let's first type it in our calculator and graph it. So 3 times 2 to the power of x minus 1 and minus 6. So I can hit graph, and I can go to second graph for the table. So some really nice coordinates: 1, -3, 2, 0, and 3, 6. Right there. Now let's take a look at the graph again. Now, all of these models, exponential and logarithmic, have asymptotes. So I have to remember which one has which. Now, this one is an exponential model. So it is going to have a horizontal asymptote. What I mean by that is there's a y equals line that sort of it levels out at. So by looking at it, and even if I were to zoom out, it starts to get more defined and leveled out there. So where is it leveling out at? Well, if I look at the graph, 1, 2, 3, 4, 5, about y equals -6. So I need to draw that on there. 3, 4, 5, 6. The dashed line at y equals -6. And interestingly enough, where does this -6 comes from? Well, it comes from right there in the equation. Outside is a vertical transformation, and it goes down 6 units. So instead of defaulting to 0, it's at -6. Then I can draw the rest of this. Now, y is a matter of range. So my domain is actually unaffected. I go left forever, and I would keep going right forever. So my domain would be -infinity to +infinity, or all real numbers. And my range actually gets stopped at -6. That's as low as I go. And it would go up forever all the way to +infinity. Number 3, same process. Let's graph it. So I have log base 2. So log, I can go to math down to a. Log base 2 of x plus 4 plus 2. And I, of course, can graph it. So again, they all have asymptotes, but this is a logarithmic, so it's going to be a vertical asymptote, aka it's going to be x equals something. Well, where does the line get stuck? That'd be about 1, 2, 3, 4. So it actually is, my vertical asymptote is -4. Think about again, where does this -4 come from? I'm actually right there on the inside, but it gets opposite because it's on the inside. Otherwise, I need some coordinates. So let's grab some coordinates. So second graph, I get -3, 2, -2, 3, and 0, 4. So in my calculator, my graph looks like this. I need to remember that my graph technically goes down forever. The calculator struggles with that, so please remember. Now, domain, my asymptote's an x equals, which affects my domain, which means my range is unlimited. I go down and up forever. Domain, left and right, I only go to -4, but I go right forever. Number 4, simplify the expression. So let's start with the numbers first. I'm dividing. So how can I simplify 15 over 25? Well, they're both divisible by 5. So I can turn that into 3/5. And then I can worry about these guys separately. Well, they're stacked on top of each other, which means I can subtract the exponents. So 13 minus 6 is e to the 7th. So we're going to get 3e to the 7th over 5. The e goes to the top because that's where the highest exponent was. Here, I am multiplying with the same base, so I would simply add exponent. So I'm going to get e to the 11. Here, because I'm multiplying on the inside or dividing on the inside of a radical, I can do them separately. So I can do the square root of 64 and the square root of e to the 8th. Well, the square root of 64 is pretty easy. That's going to be 8. The square root of e to the 8th is a little bit more complicated, except if you remember that this is implied 2, and I can rewrite this as e to the 8 over 2, and then I can just do 8 divided by 2 in the exponent. 8 divided by 2 in the exponent gives me e to the 4th. So my answer, 8e to the 4th. Okay. Number 5 is all about, do you remember about spiraling? So I can spiral this. So I'm going to get 4 to the power of 3 equals 64. And here I can spiral, so I'm going to get log base 3 of 243 equals 5. Nice thing about these, I can type them into my calculator and double check. If I type 4 to the power of 3, I should get 64. If I type log base 3 of 243, I should get 5. Okay. On to page 2 then. Number 6, evaluate round to the thousandth place, which would be 3 places at the decimal. So when I see evaluate, I'm just going to type them right into the calculator. So log base 2 of 128. It's going to be math A. Log base 2 of 128. And we get 7. Letter B, natural log of e to the negative 9. Natural log. E is second natural log. So negative 9 is the exponent. We get negative 9, which makes sense because natural log and e undo each other. And then log of 10,000. We get 4. Log base 5 of 48. Again, I'm going to go math A. We get 2.405. E to the negative 4/5. We get 0.449. Okay. Number 7. Number 7 is all about asking, do you understand the properties? So remember that if I have something like log of x plus log of y, and I'm adding on the outside, that's the same thing as multiplying on the inside, x times y. Or if I have something like log of a, I'm sorry, minus log of b, I am subtracting on the outside. So I am actually dividing inside the logarithm. And lastly, if I have a number out front, that can also be an exponent for whatever is inside my logarithm. So here I'm seeing I'm dividing, so I'm going to break it up as a matter of subtraction. And then I'm seeing that I'm multiplying right here, so I'm going to break that up as a matter of addition. And then there's nothing else I can do, so I'm just going to put that in my answer box. So expanding, I'm taking one thing and I'm breaking it apart into multiple. Condense, I'm going to take multiple and shrink them down into one. So the first thing I'm looking at, I'm seeing this 6 out in front. Well, because it's out in front, I can write it as an exponent. So I get log of 5 plus log of x to the 6th. And now I am adding, which means I can multiply the insides together. So log of 5 times x to the 6th. Excuse me. Okay. On to number 8. Here, because I have two things with exponents, I want them to have the same base number. But I have 6 and 36. So I have to recognize that 36 is the exact same thing as 6 squared. So I'm going to take 6 squared and replace it in for 36. So I'm not doing anything to the left-hand side. I'm just going to rewrite it with 6 squared, and then I have this 3x minus 5. Well, now I have this squared, I have to distribute this. Okay? Same base number, so my exponents have to be equal. And there I can just get my solve for traditionally, so minus 2x, add 10, we get 4 equals 4x, divide 4, x equals 1. And that was part 1 of the review. We'll do the rest here the next day. And then our test will be following. Thank you for listening, and I hope you have a great day.